It is.
So, anyone who can let me know where we stopped on last time? So, expected value and variance we completed. කොහෙද නැවතුනේ කියලා පොඩ්ඩක් කියන්න පුළුවන්ද? The last session. The lesson stopped at where? අන්තිමට නැවතුනේ කොයි හරියද? Expected value variance එටික් කරාද අපි? Random variables is completed 1.1. Where we stopped on last? එදා අපි කොතනද නැවතුනේ? Random variables කියන ටික ඉවර කරාද? කොයි හරියද අපි නැවතුනේ නම? 1.1 session 1.1 is okay.
Yes, ma'am.
So shall we start 1.2? 1.2, have you got that note? 1.2, expected value and variance. Have you got that note? Note එක ආවද? 1.2.
Yes, madam.
Yes, right. Shall we start from there? The expected value and variance. So before that, I'm going to summarize which we have done. So the last session. So that is what there is one the important definition of that lesson as random variable. So what's that random variable is the one. So then it is the numeric value assigns to the any simple event on a sample space. I think I explained about the random experiment, sample space, and simple event. All three definitions I completed. So what is the, so then the random variable is the required one. The random variable is what? So then we are going to assigning a numeric value to each simple event on a sample space. Random variable එකක් කියන්නේ sample space එකේ තියෙන simple event එකකට numeric value එකක් අපි assign කරන so then as the variable. So that is called the random variable. And there are mainly two types of I explained well the random variables by using the examples. So then there are some examples available with your sample space with already numeric values. Sample space numeric values. So I already explained regarding that. And then not only that, so then sample space, so then with some text values. So then how we turn them into a number value, and so how you get that, so how you define your random variable. These kinds of things I completed. And then what will happen? So I explain again. So there are mainly two types of random variables available: discrete and continuous random variables. So what are the discrete random variables? Discrete random variables are the random variables can take specific values in a given range. Again, range එකක් ගත්තාම හැම value එකම ගන්න බෑ. There are some specific values. Once you take a range 0 to 5, so then the random variable can take only 0, 1, 2, 3, 4, 5 only. So then that is a discrete random variable. So what about the continuous random variables? The all continuous random variables can take all values in a given range. Range එකේ තියෙන හැම එකම ගන්න පුළුවන්. It can take all values in a given range. Now that is the nature of a random variable I explained. Right. So then again, why we explain about the random variables. So then I turn to the concept of what? So concept of a probability distribution. Probability distribution. So there are so now here, if we make the probability distributions can be represented mainly in two ways. What are those two different ways? It can be represented as a form of a function or form of a table. Table function. So we can represent the probability distribution anyhow. So then content that the values that random variable can take with their respective probabilities. So then all probability distributions contain with the values that random variable can take with their respective probabilities. That is a probability distribution. And then I'm going to explain. So I already explained what is the probability distribution of a discrete random variable. Probability distribution of a discrete random variable, so can present by using those two ways. What are those two ways? As a table and as a function. Table function so we can represent them. So what? But so it is for user-friendly manner is represent them as a table. Table so then that is the user-friendly manner. So then I construct some probability distributions. So given that a simple random experiment, and then I define a random variable, and then so now you construct the probability distributions. So very simple random experiments are given. So then the random variable is given. So then we decide what are the values that random variable can take, and we construct that table. So it can be represented as a function also, but easiest way is make them as the table. Right. Then that is, and then one more kind of example. Sometimes they already given the probability distribution as a table form with some unknown values. I explained that how to get that unknown value. There is a property of that table. The whole sum of all probability is equal to 1. So by using that, you can find out any unknown value is available in that probability table. And then some evaluation of probabilities by looking at a table. So up to that we completed. And finally, I explained. Finally, so probability distributions of that is regarding probability distributions of discrete random variables. The continuous random variables. What's a continuous random variable? The continuous random variable is the one the random variable can take all values in a given range, but it cannot be represented as a form of a table. It cannot be represented as a form of a table, only a function. But these functions are not like your algebraic functions. So when you are in level 3, you learn about a lot of functions. The linear functions, quadratic functions, they are very simple. So sometimes higher order functions, the linear function is so easy regarding in detail, linear and quadratic functions. So anyhow, but this all these algebraic functions, we have terms of x only, x or powers of x. But in these probability functions are very complicated. So then you have, sometimes it may be some logarithm terms, exponential values, so very complicated functions. So then once you are going to evaluate probabilities, by substituting through this function, it is not easy. It is very difficult. So therefore, in case of continuous probability distributions, I'm going to explain them in data under your section 1.5. So now we are going to study the shape of a graph. So there are some special formats of the shapes of the probability graphs. And then we the study about the shape of a graph and area of that graph is equivalent to the probability. And total area of that functions is equal to 1. Why is that? The total probability is equal to 1 in a discrete one. Now here total area. So now in the continuous probability distributions, we can't add up the values. So if you are going to calculate the range of a probability of a discrete distribution, now let's say you need to calculate probability in between, say that 3 and 5. 3, 4 and 5. So then you add P3 plus P4 plus P5. But in case of the range of 3 to 5, your continuous probability distribution, there are infinite number of values. Again, there are no separate values. So then the addition is not valid. Other than that, so then I don't know whether you are remembering now. So then there is one technique is available as an integration. So we can integrate a function in between two limits. Integrate like a differentiation. There is one, the mechanism is available as integration. So then result of an integration is an area. Integration technique is not easy like an addition. You all know how to add. So then integration is not easy. But result of an integration is an area. So therefore, in continuous probability distributions, how we calculate probabilities? So we study the shape of that curve. So we are going to evaluate the areas of the given two limits. So there are some distributions. The areas they already calculated and given as a table. By looking at the table, we can find the area. In the table, that is a technique we are using about the continuous ones. Now we'll see it later. Now we are in the discrete distributions. Now turn to the today's lesson, expected value and variance. Expected value and variance in section 1.2. So what is that? Expected value and variance. Now read your note, expected value and variance. Now this class I'm conducting, so then I missed the class on last Thursday because of my personal matter. So that's why, so then your normal class date is the Thursday, 9 p.m. or 8:30 p.m. Now, Samani Thursday, last Thursday I couldn't conduct the class because of one of my close relations has passed away. The funeral was done on that day. In the Matinda very funeral. So that's why that's why the today's class. Other class. So then your participation is necessary for all these classes. I don't like to miss any one of these classes. මම class miss කරන්න කැමති නැහැ. ඔයගොල්ලන්ට මොකද මේ exam එක තියෙන හින්දා. ඒ හින්දා so then your participation is necessary. Right. Now look at 1.2 expected value and variance today's lesson. The expected value and variance. Now, first of all, we'll see what is an expected value. Which has been denoted as EX. The notation is EX. So what is the expected value? Now look at the expected value of a particular random variable is the expected value of a discrete probability distributions. So now this expected value and the formula I'm going to give you, it is based on the discrete probability distributions. That's why the expected value of a discrete probability distribution, the expected value of a particular random variable is its mean. What is the expected value? Expected value is a mean of a probability distribution. So then all frequency distributions, when you are in level 3, okay, so we calculate the arithmetic mean and standard deviation. Various measures are there. Arithmetic mean, standard deviation. So like that, this is a probability distribution. So then these probability distributions has a mean and a variance or standard deviation. Now then expected value is a name we are using for the mean of the discrete probability distribution. Discrete probability distribution mean expected value. The expected value of a particular random variable is its mean. It can be evaluated by using following formula and it is denoted as EX. So then expected value we normally denote it as EX and there is a formula to calculate the expected value. What is that formula? EX is equal EX. Expected value is equal sigma x into px. What is this formula? So the value of random variable multiplied with its corresponding probability. So can you remember the discrete probability distribution? The table format is very easy. So we represent them in most of our situations as a table. So now let's say there is a random variable like it can take values 1, 2 and 3. If the probability is as 0.2, 0.5 and again 0.2. Like this, assume that. So what is your expected value? Expected value is multiplying its probability by the 1 into 0.2. That is 0.2. X into px. And again 2 into 0.5, 1.0. 3 into 0.2, 0.6. Now then total value of that. That is 1.6, 1.8. What is your expected value? Expected value is 1.8. Multiplying the probability with its respective, the random variable 1 into 0.2, 0.2, 2 into 0.5, that is 1, 3 into 0.2, 0.6. So then what is your expected value? 1.8. That is your expected value. Expected value is the mean of a discrete probability distribution, can be computed by using this formula. Can be computed by using this formula. Right? Now then look at the variance. Variance of a discrete probability distribution. The chance, possibility of expected value of a random variable to be dispersed is computed as its variance. Can you remember in your frequency distributions, what is variance or standard deviation? There are some kind of measurements we learn about the measure of central tendency. Arithmetic mean, median and mode. As a measure of central tendency, all those are representative measures. Where data set represent measures to mainly arithmetic mean, median and mode. So now around there are central measures. So the most important one out of that is arithmetic mean. Arithmetic mean. Around the arithmetic mean, the data figures are well spread out or closely together, can be computed through a formula standard deviation. Data well spread out. Spread like a radius of a circle. So we compute a measure which is known as a standard deviation or sometimes variance. Square of a standard deviation is variance. Again with the same meaning. Now look at the chance of expected value of a random variable to be dispersed is computed as its variance. Around this expected value, so then what will happen? Probabilities. So what is the nature of the probability is spread out. So can be computed through a formula variance. So then it is denoted as VARX, the variance of a probability distribution, variance. What is your variance? Has a formula sigma x square into px minus square of px. That's my variance formula. Now this is your formula for variance. So now we can evaluate standard deviation also, square root of this one. So then standard deviation is a square root of variance. Standard deviation is square root of variance. Square root of variance. Right. So given that the probability distribution, the discrete probability distribution, we can calculate all three values. Expected value, mean of a distribution, variance. If we needed to calculate a variance, which columns to be added? A column has square of x and x square into px. So then you square your random variable 1, 4 and 9. 1 with 0.2, again 0.2, 4 with 0.5, 2.0, 9 with 0.2, 1.8. 3.8, 0.24. This column is 4. Right. Now we can calculate variance as sigma x square px, 4.0 minus square of 1.8. So once we simplify it, so we can calculate the variance of a distribution. Given that a discrete probability distribution, so then that is x and px. So based by using, so then square root of variance is a standard deviation. Variance again up to the standard deviation and given that a probability distribution, so then we can compute expected value and variance both as if we needed standard deviation also by using these three formulas by adding the additional columns. So x into px, x square and x square into px. So then by adding those necessary columns, so we can calculate all these three figures. Expected value mean, the variance, and the square root of a variance is the standard deviation. So that is your lesson 1.2. 1.2. So then given that any discrete probability distribution, how we calculate expected value and variance. So if we need it, so standard deviation also can be computed. So then here I have given them as a note, standard deviation is equal square root of variance. Right. Now there are two worked examples are there. Now we'll see. Now then we can work out our exercises also. It was a exercise right. Now read your worked example 1. Worked example 1. So before that, so then understood that part? What is an expected value and variance? Understood that? So how we calculate that? Understood? Understood that? I need your comments. Terunada? Yes, right. Now read your worked example 1. I'll come within 5 minutes. Now we are parking in now. Read your worked example 1. Right. Now again. Now read the worked example 1. It has been revealed in a survey that 5% of the boxes of matches said to be having 50 matches, said to be having 50 matches are containing 48, 10% of the boxes containing per 49 matches, and 60% of the boxes containing per 50 matches, and the rest 25% containing 51 matches. Considering the number of matches that may be contained in a box as random variable x, construct a probability distribution of x. So then, second question, evaluate expected value and variance of a distribution. And third question, find the number of matches needed if 10,000 boxes of matches to be made. Now look at this one. Now why we calculate? Now this is the real practical situation. What is that? So then normally inside a box of matches, how many matches? So then normally they indicate that there are 50. 50 So even this box of matches are making in handmade or by using a machine or whatever. So can you now, let's say you are going to making as your example 10,000 boxes. So then is it practical to get each and every box, inside each and every box exactly 50? So that is impractical. Your theory is to be like that. Theory that's what. So then the each and every box to be contain 50 matches. So then, but it is very impractical. So even you are doing this in the handmade process. So can we, so then there may be some human errors. So then there may be some mistakes. That is our reality. So then once you are going to trying to making, let's say not 10,000, 1,000 box. So then it is very impractical. Even by using a machine making so then it is very impractical. Now let's say you are going to fill in the cool drink bottles. So then the bottle contain, it is as 300 milliliters. Both 300 milliliters kila. So can we fill each and every bottle as 300.000 milliliters? So it may be lies with a particular range. It is not like 250 milliliters. So then it is lies in between like 295 milliliters and 305. So like this, once you are going to packing the box of matches, each contain as 50, it may be varies in between like 48 up to 51. So there may be a particular range of values. That is our reality. So the theory is there should be the 50 matches inside a box. And reality and the practical instance is different. Theory as an example, so then you have another lesson for the best. So you have one lesson as regression analysis at the last of the, there may be like 4th lesson in your syllabus. So then the lesson is regression analysis. They explain well. So as an example, now let's say the lot of girls you are wearing jewelries. So then the gold that you are making jewelries by gold. Gold is very valuable metal available in your periodical table. Periodical table okay, so then it is the most valuable metal. So then that is at the valuable, that is not the most one, the before that. The platinum is the most valuable. Platinum silver, gold, and platinum. That is, these are the last 3 metals available in our periodical table. So then what will happen? That is, anyhow, it is the very valuable metal. So once you are going to making jewelries by using the pure gold, again, gold, so then Right, there may be a connection. Okay, once again, huh? Right. Right. So now in example, I think you can understand what is that. So then the random variable X is number of matches contained in a box. So then so they ask you to construct a probability distribution for X. So what are the values that X can take? Before we construct this, can you tell me what are the values that X can take? Random variable X is number of matches. What are the values that X can take? What are the values? Anyone who can tell me what are the values that X can take? Can you hear me? What are the values that X can take?
48, 49,
Yes.
50, and 51.
And 51. Yes, very good. So values that X can take is 48, 49, 50, and 51. Right, now we can construct a probability distribution. The first answer, probability distribution for random variable X. Now you work example 1. Work example 1. So the probability distribution for X. For X. So X is number of matches. Right, now we can construct our probability distribution X and Px. (48, 49, 50, and 51. So with probabilities 0.px, 5% of it. 10% contain 49, 60%, and 51 is 25%. Once you add all these figures, your answer is 1. Your answer is 1. Sigma px is equal 1. Sigma px is equal 1. Now this is your first answer. First answer, construct a probability distribution for random variable X. So then what is the second answer? Evaluate expected value and variance. So how we calculate expected value and variance? So we have to add the necessary columns for expected value and variance. Now look at your answer number 2, expected value and variance. Second answer, expected value and variance. Now add your necessary columns. Only expected value, one column. Expected value kila vitarak tibuno, sigma x into px only. So now this is x and px. So expected value only we have to add x into px. Make a vitarak. But here variance also they needed. Variance according the 2 more columns to be added as square of x, square of random variable, and x square into px. Now these are the columns needed to be added. 48, 49, 50, and 51. So complete your table. X and Px is given 0.05, 0.10, 0.60, 0.25. Right. Then multiplying together. So then first and second column. So to complete the third column. So 48 into 0.05, 0.05, that is 2.4, 2.4, 49 into 0.1, 49 into 0.1, 4.9, 4.90, 50 into 0.6, 50 into 0.6, 30, and 51 into 0.25. 51 into 0.25, that is 12.75. Then square your random variable. 48 square. 48 square is equal to 2304. 2304. At the same time, multiplying with the respective probability. 0.05, 115.2, 115.20, 115.20. Then 49 square, 49 square, 49 square is 2401, 2401, multiplying them by 0.1. So that is 240.10, 240.10. 50 square is 2500, 2500, 2500 by 0.6, that is 1500, 1500. So 51 square, 51 square, 51 square is 2601, 2601 by 0.25. That is 650.25. 650.25. Now take sigma px, sigma x into px and x square px. Sigma px is 1, make it chi. Sigma px is equal 1. So what is sigma x into px? Sigma x into px is the 2.4, 2.4 plus 4.9 plus 30 plus 12.75. So that is with 50.05, 50.05, 50.05. Then again last column, no need to add this column. Sigma x square into px. What is sigma x square into px? 115.2 plus 240.1, 240.1, 1500, 1500 plus 650.25. That is 2505.55. Right. Now you take the required totals. Now calculate expected value and variance. What is your expected value? Expected value has a formula. Expected value Ex is equal sigma x into Px. So then no need to do any other calculation. Now you just take your directly the total of third column. What is that? 50.05. Taken of 50.05. The expected value is 50.05. So what is your variance? Now it is to be calculated. Variance x is equal sigma x square px minus square of ex. Square of ex. Now this is formula for variance. So that is Vrx is equal 2505.55 minus square of 50.05, square of 50.05, 2505.55 minus 50.05 square. That is 2505.00. Decimals දෙකට ගත්තාම ඇති. So what is your variance? 0.55. Variance is 0.55. Now this is the second answer. Expected value and variance. So then if you need standard deviation, take a square root of that. Standard deviation, I would make a square root again. And what about the third question? Now this is the most practical question. So what is that? Now expected value. First example, 0.55. So, how many matches to be needed once you are going to making 10,000 boxes? 10,000 boxes. So then in our theory is how many matches to be needed? 15 to 10,000, that is 500,000. Appa theory ekana, apita only 500,000. But it's the theory is, so then in a practical instance, so now we have the expected value is not 50. අපේ දැන් මේ දීලා තියෙන survey එකේ හැටියට what is the mean of a distribution? Mean of a distribution is not 50, that is 50.05. Why? Because of this one. So the number of matches are not exactly 50 in each and every box. හැම box එකේම 50ක් නෙමෙයි තියෙන්නේ. According to this survey, 5% of them has 48, 10% of them has 49, 60% has exactly 50, but 51 is there for 25%. මෙන්න මෙහෙම තියෙන්නේ. හරියට මේ හැම එකෙම 50 ගන්න නැහැ. So then now the ones you are going to make according to this survey, how many matches to be needed once you are making 10,000 boxes? According to our theory, this would be 500,000. හරියට theory එකේ හැටියට නම් අපිට 500,000 තිබ්බාම ඇති. මොකද 50 10,000 into 50 is 500,000. But here really what will happen? 50.05. The number of matches needed for 10,000 boxes. Number of matches. Third answer. So what is that? 50.05 is to be multiplied by 10,000. Remember here accordingly. That is 500,000, 500 matches. 500,000 නෙමෙයි තව 500ක් වැඩි කිව්වොත්. Now this is your number. According to our theory, that's only 500,000. But it is not our practical way. අපේ practical way එකේ හැටියට. So that's why we need to calculate the uncertainty. What is the mean value of this uncertainty? May uncertainty, අවිනිශ්චිතයේ uncertain thing, what is the mean of them? Now it has given not 50, 50.05. Take a 50.05 කියලා දීලා තියෙන හින්දා. So then how many matches to be needed for making 10,000 boxes? 10,000ක් හදන්න 500,500 matches to be needed. So that's why we calculate. So then all things are not according to our reality. All things are not according to our theory. So then the practical instance is different. So that's why they are introducing probability. Lot of uncertain things met with us. So now this is the mean of your uncertainty. So calculation is, I think, okay, all of them. So there are some formulas. So then you can construct a distribution. So then you can do all necessary calculations and then can work out. So then why we calculate them? Because of this. Right. I think you have a small idea why we calculate the expected values and variances. So there are a lot of in business field. So then we need this kind of calculations. So if we take exactly 500 batches, so then we can't manufacture 10,000 boxes. So that's why we calculate them. Right then, again, the next one is, this is the question from your the textbook. ඊළඟ textbook එකේ තියෙන ගානක් මේ වගේම එකක්. Now look at that. Example 2. A manufacturing company in Sri Lanka used to purchase accessory from China. As these accessories are very expensive, it is not available in stocks. So they use the air freight for fast delivery. Therefore, after placing an order, it takes few days for transportation. Company experience that lead time for transportation is vary from time to time. As per the past records of the company, the probability distribution of lead time for transportation of occasions in 15 develop as follows. So what will happen? There is one expensive accessories available. So then this accessory is not available. So then that is very expensive part. So then they are not available in as stocks. Stocks there are a lot of practical situations. So some parts of medical equipments in some other parts are very expensive. So then it is not available in stocks. So therefore, if we need, so then they import them through air freight. Air freight transportation time. So then they make a survey and then the number of days. So then your random variable exists number of days. So 12 days with their respective probabilities. Distribution. So then for 12 days, 14 days, 15 days with their respective probabilities. 12 days with 1.5%, 14 days 5%, 15 days 10%, 16 days 40, 17 days 25%, 18 days 41, 19 days 1%, and 20 days 2.5% with their respective probabilities. Anyhow, lead time. Again, transportation යන කාලය සහ probability එක දවස් 12ක් වෙන්න 1.5% 1.5ක් විතර. එතකොට 14 days 5%, like that they construct. So then find the average lead time for transportation. What do you mean by this one? පළවෙනි ගානවා find the average lead time for transportation. What is average lead time for transportation? That is your expected value. Second one, find the standard deviation. So how we calculate the standard deviation? We have a formula for variance. So then can calculate the standard deviation by taking a square root of that. Take a square root එක ගත්තාම අපිට standard deviation එක ගන්න පුළුවන්. Find the coefficient of variation. මේක නම් ඔයගලන්ට මතක නැතුව ඇති. Coefficient of variation is the level 3. That is the standard deviation over mean into 100. There is a figure once you are going to comparing two or more distributions. We calculate a particular measure. Once again, we consider them as the measure of the dispersion. Dispersion category එක අපි එක measure එකක් define කරලා තියෙනවා as coefficient of variation. So that is a measure without any units. The reason is normally the standard deviation is varies with its mean. හැම වෙලේම standard deviation කියන figure එක mean එකත් එක්ක වෙනස් වෙන්නේ. Your standard deviation is too high, mean is the highest value. Standard deviation is a value like, say, mean is a value like 100 වගේ එකක් නම් standard deviation may be a value with 2 digit or 1 digit figure. Again, it's 7, 8 වගේ එකක් හරි 12, 15 like that. You have the mean is like 25,000, standard deviation may be 3,000 like that. So therefore, once you are going to comparing distributions compare karnකොට the measures can only measure standard deviation does not give a correct idea. හරියට මේම idea එකක් දෙන්නේ නැති නිසා, so we just define a measure which is known as coefficient of variation, that is on level 3, standard deviation over mean into 100. Normally mean and standard deviation both having same units of measurements. මේ දෙකටම තියෙන එකම ඒකක. ඒ හින්දා ඒක බෙදනකොට ඒක cancel වෙලා, so we just to have a number once you are going to comparing distributions. ඒකටයි අපි මේක පාවිච්චි කරන්නේ. So anyhow, here they ask you to calculate the coefficient of variation. Make it mean, so we can calculate mean and standard deviation both. So can we compute coefficient of variation? It was my figures. How might the company use the above survey measures? What may expected value variance make. So the previous example, so it is the useful. So once you are going to making like any number of box of measures, so then how many measures to be needed? So I will explain some reasons are there. So anyhow, we have to go through our normal routine. Our routine we have to calculate expected value, standard deviation, the variance as a formula, standard deviation can be computed, and coefficient of variation also can be computed. And then, so why we use that? One comment. Right. So now we'll see the worked example 2. Worked example 2. Worked example 2. Now, first of all, calculate mean and standard deviation. Prepare a table. I already prepared this table. So our probability distribution is given. Make a distribution like so lead time is number of days, lead time. That is number of days for the transportation. X and Tx is given. So 12 days with then 14 days, 5%. මේක දැන් 13 නෑ කියලා ප්‍රශ්නයක් නෑ. මේ සර්වේ එක හැටියට හරියට මේක ළඟ තියෙන ඉලක්කම් ඕනේ නෑ. No need to get the consecutive numbers for the random variable. 13 days වල probability එකක් නැතුව ඇති. So then that is not necessary. 15 days 10%. 15 days 10%. 16 days 14%. 17 days 25%. 18 days 41%. 19 days 1%. 20 days 2.5%. Like that. So we given that. So then what are the columns needed to be at? X into Px. Multiplying together. And square the random variable x square into Px. Now these are the columns needed to be at to calculate expected value, variance, and standard deviation over. Right. Now make a balagana. So then you know the method, no? So I just put the figures. I already work out the 0.180 multiplied by 0.5 into 14, 0.700 and 0.1 into 15, 0.14 into 16, 2.240. Check this. And again 0.25 into 17. So that is 4.250. 4.41 into 18, 7.380, 7.380, 17 square is 289. 17 square is 289. That is 289. So 289 into 0.25, 72.250, 72.250. So 18 square is 361, 324, sorry, 324, 324 multiplied by 0.41, that is 132.840. And again 19 square, 361, 19 square, 361 by 0.01, 3.610. Then 20 square is 400, 400 multiplied by 0.025, 10, that is 10. Now these are you complete your table. Then take your totals. So then you need to take sigma px. Once you add all these figures, that is 1. Sigma px is should be equal to 1. Make a cut. Sigma px is 1. Sigma x into px. Sigma x into px. What is that? Sigma x into px is 16.94. We'll check it. 16.94. 0.7 plus 1.5 plus 2.24, 24 plus 4.25 plus 7.38 plus 0.19 plus 0.5. 16.94. This is 16.94. The last column. Sigma x square into px. Sigma x square into px. 2.16, 9.8, 9.8, 2.5, 2.5, 35.84, 72.25, 132.84, 3.61, 3.61 plus 10. 289, 289, 289. Check the total again. Product total check around 9.8, 9.8, 22.5. This is 22.5. Sorry.
Madam can't hear.
Excuse me, ma'am.